Alright, today I'm going to be working on the continuing work on the transformers performance issue that I was working on yesterday. This is a regression that was introduced in a recent version when I switched over to transformers library. Before I do that, I want to do a little bit of faffing around with audio. This isn't the smartest way to do things, but basically I'll just go to the stream in my browser and listen to it. So I'll be switching this on and off again for just like, a minute or two. Today I'm going to be working. Alright. I'm going to be working on the continuing work on the transformers performance issue that I was working on yesterday. This is a regression that was introduced in a recent version when I switched over to transformers library. Before I do that, I want to do a little bit of faffing around with audio. This isn't the smartest way to do things, but basically I'll just go to the stream in my browser and listen to it. So I'll be switching this on and off again for just like a minute or two. Okay, so I don't understand why the audio was on when I was initially fiddling around. That's not how I thought this worked, but I thought you had to select a specific audio source, but it seems that the audio just comes there by default. So let me see if I do this. If I remove this, does this actually make the audio clearer? Alright, so now you just transition around. Okay. Alright, I'll need to look at this properly later. I'm still very surprised that the audio's on when I had no scene selected, but I can't be bothered going through it more at the moment. So yeah, okay, I'll get started. I'll just type a couple of notes in the chat. I'm just going to find the issue. Here we are. Oh. Yeah. All right, so yeah, yesterday we got a patch to this, to the spaCy curated transformers library, which I think resolves the issue, and then another patch to the underlying curated tokenizers library that fixes this regex issue that was also reported on the issue. That's basically just a patch which was suggested in the issue, so big thanks for that. So the next thing to do is actually just to check whether we've changed the accuracy on the models. So for this, we need to run the experiments that we run with library to verify this. So let me just briefly in the browser remind myself about all of this. So just switch over here. Okay, exclusion and spaCy models. So if we go to this repo, so this will be the first thing to do. We can run the spaCy model tests. Yeah, okay, so let's go and run those ones. That's a good start, and then if this all works, then the next thing to do will be to actually run the accuracy evaluation. So, checking that the model is all installed and loadable. Nope. Okay. It's required for a normal function in this module, but found tokenizers equals 0.21.1. So this could be a problem actually. Oh, okay. So wait. Here, let's just trace through this a little bit. So the worry here is, do we have the default being called WebTRF model set up such that it actually depends on transformers and spaCy transformers? And if so, yeah, I think these are just being read as entry points. So I think we can actually just uninstall this. So the worry here would be that that version of tokenizers that's being referenced there actually doesn't have wheels for 3.12, and if there's no wheels, then things need to be compiled and it just becomes a mess. You end up needing like a Rust toolchain and stuff, which really isn't what we want. So let's just check on this. Yeah, sweet. Okay, so this is good. And then, okay, so according to this, I need to say model in forward trf lang en has parser, has tagger, has enum, has morphologizer, has limitizer, has segmenter. Okay, so we already see a couple of errors here. What do we got here? Assert morphologizer. Okay, well, this was just my mistake. We do not have a morphologizer in the English pipeline. What's going on here? Ooh, is this a Cython 3 change? This looks like something that can't possibly be related to okay. Yeah, so this failure is unrelated. This is something that I should have caught in the release process for spaCy, for the latest version of spaCy. The question is what the implications actually are. So in what way does this type here not behave like like, is it just a type label that's different? D equals P. Yeah, okay. D, 2 dot plus. It's not great. Sweet, okay, that's something. Alright, so it's not a huge deal. We're going to get, this will be different, I'm sure. Okay, so, yeah, alright, so that's fine. That shouldn't be expected. Can you do addition with it? Plus 1. Sweet, okay. That's good. So yeah, I'm wondering what difference this difference will make. Let's do a little bit of research on this. Copy all item names into the global module namespace so they are available both as attributes in Python enum type and global constants. This was changed. Distinguish between anonymous, blah blah blah, for your items and named to create global constants also. Yeah, okay. So this is a change that we knew about and we made an edit, but I think that the way we did it was unideal. So let's look back at this. You see, I think it was in arrows.px. So names, yeah. Locals.update IDs. So I reckon what we want to do here is actually call int on all of these. Why is this written like this? Oh, because we need to sort it by the item value, not by the name. Okay, yeah, that's fine. Alright, so that's a change that I think we want. And then, where was the other one? I think in the parts of speech, .qx. Names. Okay, and then Alright, should run the CI. Cool. Alright, so other than that, we were looking good here. Let's just double check that the parser that the tests are exercising what we think they should be exercising. So, parser? Yeah, just parser, okay. Why is this one being skipped? Tests. Test type. Let's see whether we actually get resistance here. Might be that actually just a literal type check is not good. So we've got phase. Let's go and have a look at these. What? Underscore util. Maybe it's an unrelated change. It's doing something I pulled before. Okay, let's fix Python types. Alright, let's see about that. So this should really be an X fail. Oh, that shouldn't cause seg faults, what the hell? Oh, okay. Alright, so that's fine. Cool, alright. So why does this one fail? You wouldn't expect that to fail. Okay, so these issues with the quotations and stuff, these are things which segmenter, yeah. No object string. So these are quite old tests. The sentence boundary performance here does seem really bad, which is surprising. I guess if I'm only looking at the errors. But still, you'd think it would get that stuff right. Cool. All right. Okay, so let's just do a quick update. Now, I bet the other tests for okay, so we need to we need to fix that one. Yeah, so that has the same, okay. Just run the test tagger. Cool. All right, so now the next thing to do is actually run the evaluations. So let's see. Okay. All right. So does this make it actually easy to run the experiment? I'm not sure about that. This might not be the easiest way to do this. Let's see. Let's see. spaCy corporate -3. I'll switch over for a second because I think I need to do some authentication. Alright. Just turn things off. Okay, cool. So I have the corpus now. God. No. Okay. No. Okay, so these are the JSON versions. So let's see. Convert, is it? Let's see, convert and in core web and then output processed. I think this should work without, I think this should figure out what to do by itself. Yeah, this looks good. So this corpus is the is our processed version of the Ontonotes 5. So this is what we train and evaluate the English models on. Is this not on the right? I've been on the wrong terminal this whole time. Please don't tell me. God. Alright, well, don't know how long I was on the wrong terminal, but we'll do that. Yeah. Okay, so yeah, so to answer the question, what I'm doing, well, I'm the maintainer of this open source library, and I decided to start live streaming a lot of the maintenance. I'm trying to keep up a schedule of this. There's a couple of reasons for why I find this useful. So one is that it sort of keeps me focused on it, and the other one is over time, as more people want to get involved in the maintenance and things, there's a lot of knowledge which can't easily be captured in documentation and things. I need to be able to basically show people what I've been doing, or like point back at some bit of development to explain context around the things. So that's what I hope to get out of this, and it also shows that it provides more transparency for the community of what's going on and what I'm doing, etc. And it's possible some people will find this interesting in itself. I don't know, but yeah, I think it's helpful. So persist. Now, let's see. Yeah, evaluate. Okay, so let's see. spaCy evaluate. Rates equal with TRF, and then process dev, GPU ID 0, and then I think output scores.json. All right, so let's see, that's NER, IS. So this looks good. So let's see if we've still got, we should still have our virtual env from here. spaCy activate. So fingers crossed we can actually run exactly the same test with the previous version. Okay, so speed is still down a bit, 95.24, yeah, similar, 9.83, 99.93, okay, LAS 93.84, 0.91, 89.84, 0.93, 88.56. So the sentence boundary detection's off. I wonder what's gone wrong there. But it's otherwise similar, so that one's a bit higher. Yeah. 99.93, 99.6. Okay, so the accuracy is the same. We are still slightly behind on speed. So I've got that version of curated transformers installed. Do I have the right version of just the tokenizers? Am I in? So curated dash tokenizers is what we should be looking for here. Right. So we don't have the version of tokenizers with the fix that we just made. So let's go ahead and install that. Curated tokenizers. So this will tell us whether the whether the second performance suggestion made in the thread closes the rest of the efficiency gap. This was the one where the regular expression in the tokenizer was being compiled on each call instead of using the precompiled one. It seems doubtful that the tokenizer would actually have that big an impact, but who knows, we'll see. Okay. It's actually, realistically, it's just as possible that there's no real variation, and the second time we had the compilation caches warmed and that sort of stuff. So we'd have to run this a couple of times, and this benchmark's also a bit small. The difference was only 10%, which can easily go up and down. It's actually quite difficult to benchmark reliably, especially for things like GPU and spaCy. There's caches at a number of different levels, which means that the shorter tests aren't necessarily representative of longer tests. Okay, so this is very similar to the performance before. Organizers. Let's just double check that we have the change that we were talking about. So this is bbpa.pyx, and it was this regex change. Yeah, so that does have, so here we are using that final change. So that one makes little difference, which, just makes sense. Cool. Okay. But the upshot of all of this is that we can, so let's actually check that the spaCy curated transformers difference makes a good difference. So where are we on that? So we're using that version of spaCy curated transformers. So now, let's see, we want to see. spaCy. Transformers. So what have we got here? Setup CFG. So this was V0.3.0. Actually, let me just double check that. Yeah, okay, so we do want 0.3. So let's see, does this install it from the web? No, okay. So we want to install it. Yeah, so we uninstall the applicable version that we had, and we install the version from the web. And now what we should see is this getting slower, because this is, so we can see whether the performance, how big a difference the performance fix really made. Okay, almost no difference, so it's, or at least a small difference. All right, so what we can report here in total is that 95.19, this is, so 95.19, 93.84, and then this sentence boundary is 88.55. Okay, perfect. So a few things here. Our change makes no difference in accuracy, which is good. It makes a small improvement in performance of about 5%, which is good. So this is quite different from the from what was reported in the original issue. So if we switch back over to that issue. So the big problem here is the way that this benchmark was conducted. So it's the benchmarking's hard. You can't benchmark like this with calling a single document, a bunch of times in a batch of one. It could be that actually, if you run this test, that we've closed that gap, which would be good, but this doesn't represent the normal usage case. So when we run the normal benchmark, we find that there's a difference of about 5%, which it's good to close that, but it's a much less dramatic change than was reported here. So overall, I think we can close this out. I'll get the change published on the spaCy curated transformers and the change published on curated transformers, that regex fix. I'll do that tonight because it's just, you know, a process of waiting for the CI, etc. And yeah, I'll update the issue. So let's just write an update here. I think I've got a 3090. What GPU is on this machine again? So my actually, this might be the A100. So NVIDIA X. RTX A5000. Okay, cool. Okay. How do I do a table again? So let's see, is that right? Yeah, that's good. Okay, so okay, so now let's get those figures. Oh, I needed to switch over to browser. Yeah, cool. Yeah. All right. So this was the before test, and we got 8445. 8823. And this is 10929. Okay. Let me just rerun the benchmark there, the same before and after. So here, wait, is this right? Did I run? Maybe this is all nonsense and I didn't even run the right test. Silly. Could have sworn I ran this though. So that's 8445. Right there. Yeah, so that's that one. Okay, yeah. This is right. Okay. So that's 10. Yeah, okay, that's all correct. All right, so let's see. We want to run so let's run this here. And spaCy activate, then and then we'll go. Okay. Yeah, so here's what I was just doing. I was just setting up this script so it runs the three together because it's too fiddly changing it back and forth the way I have been. Okay. PWD home mat repos explosion spaCy. Transformers, and we want where will we be? Oh no. transform as perf bench. Okay. Okay, transform as perf bench, and spaCy 331. Mat repos explosion, spaCy, transform as perf bench. Alright, let's just move. All right. Okay, put a little pot here. Wait, what's going on here? Oh, I changed the benchmark. Okay, that's right. So this was already changing the benchmark. Yeah. So 0.458. Seconds, 1.568, 0.568, and crap, it didn't work. 1.5. 542. So what's gone wrong here? So the thing that's surprising here is you wouldn't expect so much compilation time because, I guess it only has to compile it once, and then because the benchmark's so short, it blows it out. See, here we also get this compilation call, but this is so much faster. Let me just double check where we are in spaCy periodic transformers. Yeah, okay, so this is what should be happening. I just don't understand this. The total time is how much time is actually spent in there, right? Yeah, so this is the big difference. You spend so much time compiling. So yeah, that's the one. Okay, now backend some kernels. Let's see. Induce max. Okay, so endpoint 3x. Pad as a CUDA kernel. Add dish. Loading large temporary arrays. Make all CUDA kernels generic. This change makes all using C++ templates so they can be used for float and double arrays. Oh wow. I wonder whether this fucks the compilation time. I bet this is it. Okay, so how are we going to go about testing this? So I think what I'll do is reintroduce for the reduced mean kernels, a non-templatized one, and then go from there. So okay. One second, plug in my laptop. All right. So, 13. See you. All right, so let's review here. So yeah, just to recap again, the suspicion here is that these templates that we have for these types, so you know, hang on a second, how does this actually work? Yeah, so the suggestion is that the templates that need C++ here are slower to compile than the templates that use just C as they were before. So what we're going to do is we're going to go through here and we'll go reduce mean. So not use reduce mean here? And that's interesting as well. So it's actually a whole different, so there's no kernel for reduce mean. Where is this introduced? Reduce sum. I guess we just don't bother and use the reduce sum one. Is that correct? So let's see here. I think backends, custom kernels. So here we've got this lazy kernel approach as well. What's the deal with that? Yeah, so this, should we do this? And then we do that. Now, so let's go back to here. Now, so how do we do this before? You're telling me that we compiled them once before, and now we... Okay, so maybe it's actually got nothing to do with the C++ hypothesis. Maybe it's to do with this lazy stuff. So let's see. Wraps around CuPy.raw module and CuPy.raw kernel to verify CuPy availability and lazily compiled bladder on first invocation. So that could be bad. Let's see. Self-done compile kernel. Score kernel is none. Okay. So what do we do in compile kernels over here? Parse kernels. Raw module. So there's a number of differences here. And there's a lot of things to check. So before, what we used to do was parse the file, get the actual implementation for each kernel, then compile that individually, and use this using this Qpilot raw kernel. Then we compiled that, and we created that object, and then we were invoking it. And afterwards, so what do we do in get function? So get function calls into this Qpilot raw module. So I'm going to still guess that it's about the C++. This lazy mechanism, at first glance, it looks okay. I wonder whether I should just... So let's first verify that it's actually about this at all. So let's see, we can go all custom kernels. Okay, then so then okay, so right. Okay. So, in theory, TP, so now we want to run Python average benchmark. Oh shit. Okay. All right. Okay. Okay. All right. So what's going on here? Old custom kernels. Nothing called C. That's fine. Backends, all custom kernels. So let's set the colors there. Of course. I bet that's going to be a problem too. Maybe not. Right. So that's very suspicious. Let's just double check. Backends. Here. Okay. Yeah, okay. Alright, there's no point in updating the issue at this point. We can do a couple of more simple tests. So we've narrowed down that the changes in one of these changes to the compilation. So there's two main ones which we can see here. One is the C++ change, and the other one is the lazy kernel change. So now let's put the C specific kernel in the file which uses the lazy. Well, actually, maybe we can do this even differently. So let's see, what's the best way to do this? Custom kernel supply. So what we want is maybe something like this. Reduce mean C. Okay. Then so old kernels that don't have that option. Then name expressions. It's annoying. Well, let's just go reduce C, reduce mean C. Yeah, so some that's not what we're actually calling. Reduce some C. That's fine. And then we want to go reduce some kernel C, lazy kernel. Okay, callback, compile kernel. Yeah. Right. Yeah. Okay, so compile callback. Yeah, calls that. Though self.compile callback is not none. How does this actually work? Ah. Oh yeah, okay, cool. Alright. Equals all kernels dot get function. Subject name plus all kernels. Okay, so reduce some kernel C. Cool. So we've got that. And we don't need this. Well, we might as well keep it around. Custom. No, we just want custom kernels. Custom. Yeah, reduce some. So, actually, I'll reduce better. Okay, there we go. Reduce custom kernels dot reduce speed. Okay, and this goes reduce some. So this was actually another point where we could have done better. Yep, reduce some kernel C. That's how that works, right? Reduce some kernel C. Yeah. Okay, and now let's just verify that that's all the same way. Hold. Custom kernels.py. Go reduce mean. Cool. Okay, so reduce some kernel C, non-blocks, blah, threads per block, blah. Then we go out, X, lengths, DTO. Perfect. Alright, sweet. Alright, so okay. Yep. Cool. So, where are we? Okay, so this says that still takes 1.593 seconds. So let's dig through this a little bit. So you go qpyops reduce mean, custom kernels reduce mean, and then we call into this. So that's on 10. So So we go soft underscore compile kernel, and then we're within compile kernel, and then we spend a bunch of time in get function. So first of all, let's just verify that we're doing what we think we're doing. Okay. That's not promising. Okay, so how's this work though? We've only got 3 calls to this get kernel thing. Shouldn't we be calling into this like, I see, right. Six. How's this possible? I thought that we would be calling that function every time that we go to call, like, you know, reduce mean C or whatever. So I thought we had way more invocations of this. No, okay, so it's just, we're just calling the one text. Alright, so let's see. Okay, so what do we have for name? So do some float, do some float, do some float. So this isn't calling what we expected to call. Okay, cool. Do some kernel C. Against yeah, that's the one. Okay. Right. So this lazy stuff doesn't matter, but what does matter is that we're slower without this. We're slower with the templates. So let's make sure that we can. Let's check whether we can call this with the C++ option and see if that makes a difference. Actually, there's still another explanation here. It could be that what matters is having all of these things in the same module, and then because that's another difference. So it could be that it's still not the C++. Yeah, okay, so that's the same. So now we can go custom kernels, give you some and then put that there, then Let's try that. So that's still slow. So that's interesting. Right, okay, so let's put this back. Now where are we? So he wants test kernels. Okay. Let's just give it one of these other things to compile. So let's see. Do some. Alright, so let's say you've got this. So now we need some floats and reduce some double, and then we'll reduce some C. So what we're testing here is whether just having those functions within the module interferes with things. So here we're calling, so we should still be calling into our old kernels, which is this guy, which is then compiling this file. And the only difference should be to have added this sort of confusing. Right, so this is a bit slower. So if we add more of these functions, does it just become slower still? Okay, so now what have we got? Reduce max. Oh, yeah, that's wrong. So what? Reduce max. Yeah. So it's getting slower the more of these modules, the more of these kernels we add. Okay. So, and then, yeah, just verify this again. All right. So what we want to do is try, instead of having this module approach, we can try going back to how we had it before. So I wonder whether, when I did the original thing here with this parsing, whether I actually knew about this at the time. Maybe I tried both. Yeah, okay, so let's see. So this says extern C. So in our new one, it would be template type name. For G name array blah. Okay. Okay. So this time we'll make this point to here, and then we can point to this externally. Backends occupy. So yeah, can say all right. So we shouldn't be calling into this file at all. Okay, so we should be passing in this, and it should be going to new custom kernels, and yeah, okay, so So let's see, how did this work? Okay, so when we call it into this, we've got that, and then we call into so it's the raw module. I wonder whether this can work at all. Inside a raw kernel. Okay. Let's see. SRC. I guess we can try it like this. Really unsure about this. Okay. We didn't find the names. Template type name T. What have we got here? Okay, so we've got template, type name T or U. Alright. Type name W. Okay. Codes up here. Okay. So what's wrong with my regex? Let's see. Tempos. name art. Oh, it's actually the name that's not working. Okay, so template type name. Okay. So how did this work before? Oh, we've got the look ahead. Oh, no wonder. Okay. Yeah, that makes sense. Okay. Plus there, and then equals template. Yeah, okay. So then we can do this. Extern or templates and then we can do this there, look ahead, templates there. Okay. Yeah. So this does suggest that our approach won't work here because we've got these things. This header. Okay. So then equals NRE dot search. Let's see. Okay, now edit text equals edit dot group. Just looking up the group object in Python, regex again. Okay, and the group 0 is that. Yeah, okay, so then we can go SLC equals SLC. Right, so then yeah. Right. Okay, so what have we got? Read kernel, C float, backprop, yeah. Ah, it's a mistake there, okay. Okay, so that's a problem. Backprop mesh. Yeah, okay. So we can go so what's gone wrong here with the name? Why do we have this header at the end of this? Read kernel. Like that's the problem. Oh, I see. No, that's fine. Okay. All right, let's try that. So why are we seeing this? Like, why aren't we seeing reduce sum? So let's remove this. Might be confusing things. Yeah, remove that as well. So where's reduce sum? So that's been missed somehow. Ah, yeah. prep seek call template type name. Yeah, so void. I thought /w would get everything there. Why isn't it working? Mysterious. Read kernel backprop seek to call. Oh, yeah, this is done. Okay. So, yeah. And suppose reduce some okay, there we are. Some kernel. Well, let's just reload this for now. Okay. Name symbol not found. All right. What do we call it? Reduce main. Reduce sum float. Okay, and then Alright, so this one doesn't use these constants from the header. So let's try removing that when we compile and just compile the kernel. Name symbol not found. Okay, get function. We're doing, yeah, this is, okay. Reduce sum kernel. Reduce main. Reduce sum kernel. Oh, wait, no, that's correct. So, where are we? 115. Reduce sum kernel. Reduce sum kernel. Kernels reduce sum float. Yeah, I think I've misunderstood how this worked in the other version. So we've got our module there, and then we get it. Alright, we need to look at the CubeHide docs. So yeah, looks like this is it. It compiles the whole module, I think. RTC or MVC. Is this different? This is what we need. Yeah, okay, so that's why we need it to be. Yeah, I think that's the difference. So I think I know what was wrong with the code. It's this names list, I think. Yeah, so before we had the names list, but now we don't, because we don't have a module. So individual function attributes, any object from the module. So we actually don't need this lazy compilation stuff, maybe. Okay, so now we'll rock. Name of the kernel function. C name. So let's try this. Name symbol not found. Reduce main. So let's see. Reduce some kernel. Reduce some float. Okay. So often when I'm using these things, I try to not tell it everything I know. So instead of saying, raw module supports C++, does raw kernel, I ask it both, because if it told me that this didn't support things, then I would know to distrust. Yeah, okay. So, I think this is all a bit of a red herring, because I had thought that the compilation would happen per block size and stuff, but I think it's only going to be happening once. The other thing is this weird there's another difference. We're using, I think, NVRTC here, and before we were using NVCC. All right, I'm gonna stop this, I think. I guess I should do one more test. I should check over the larger benchmark whether using the old kernels helps. So let's backspace out of this. Okay, so okay. Let's go back to our benchmark, which was in spaCy. And TP. So now spaCy here. Right. Yeah, that's right. So, if this makes a difference in performance, then we'll continue digging at this and look at this compilation overhead in more detail. But I suspect that, we're not going to see any difference because we're not going to see that many calls into the compilation. Okay, let's see. Yeah. Okay, well, we see a little bit of difference. That's interesting. hard to tell whether that matters though. Yeah, that's within an amount that I'm willing to call noise. Alright, so when do we create the roll kernel here? So just want to see a couple of options that we have here. Roll kernel. And equals NVCC. This is clearly not right. Okay, so let's see. Okay. All right, so that wraps that up. So yeah, okay, I think I'll leave it there and come back tomorrow. So tomorrow I might look at a little bit more issue triage, but then I want to get back to the PyTorch stuff, which I started, some weeks ago before I had to move off to different things. I think if we can get that design right, I think it'll be really helpful. So I'll leave it here.